Okay, here we go. Okay, so we're starting something that's pretty new. A lot of it ties closely to trig, so it's not really too new, but somewhat new. Okay, so polar coordinate system. Okay, in the lower right corner here, that, guys, quiet please. This is a polar curve. It's very, very similar to a unit circle. So you start on the positive x-axis. If you go counterclockwise in positive direction, go around once, that's one revolution, so it'll be 2 pi. So halfway would be pi, quarter way pi over 2, 3/4 way would be pi over 2. These are concentric circles. So the first circle, each circle is raised to 1. As you expand out, the raise increases incrementally by 1. So the second circle is raised to 2, third circle raised to 3, fourth circle raised to 4, and so forth. So if I show you how you plot these points, it's actually pretty easy. Like, for example, and before I get too carried away, the first coordinate you see is r. The second coordinate you see is theta. R is simply going to be what we consider the directed distance. That's kind of the formal name of it, but I like to think of more like a radius. This right here is theta, which we call the directed angle. This right here, it's like the origin, we call it the pole, which is also right there, right smack in the middle. We call this the polar axis. Yeah, okay. So now let's plot some points. So the graph will point the polar coordinate, look in the box, polar coordinate plane. We stand at the pole and turn to face the angle. So like if you like shrunk yourself, push up on the board, and like so you're standing right there. And what you're doing is you right now you're facing towards the right or towards east. You want to do like that, and then you turn your body counterclockwise wherever angle you want to get to, right? So it's kind of like here. You then walk out a distance of r along the terminal side of the angle theta. Now, if r is negative, I have to walk backwards. So let me show how this works. So for point T, it's 2 pi over 6. So how do you plot this? And again, it's going to be really, really easy. So pi over 6 is right over here, right? So all you do is, if you're standing at the middle, you turn your body towards pi over 6, you face it, and you walk to raise the 2. So then you're going to be right there. That's point P. Now, if it's negative 2 pi over 6, negative 2 comma pi over 6, you still point towards pi over 6, and then you walk backwards.
Okay.
Yeah, that's point P. The other one's going to be point Q. So whenever r is negative, it's a 180-degree rotation from when r was positive. That's all it ever is. So for example, point A would be pi over 3 and 4. Sometimes I lose count with these concentric circles. That's A, right? I think so. 1, 2, 3. Yep. Point B, 3 pi over 4, but you got to go negative 2. Point C, negative 45 degrees, but 3. .5, 7 pi over 6. Where the heck is that one? Okay. 3.5 is between 3 and 4, clearly. So 7 pi over 6. Yeah. Just where I have it? What did I do wrong? But it's negative 2. But it's negative, right? Wait, C?
C negative 45 degrees, so 7 pi over 4.
Hold on. Oh, you're right. You're right. Sorry about that. Shoot. Thank you for correcting me. You're correct. 3.57 pi over 6. So 1, 2, 3. Yeah, it's right here. E, 4 pi over 3. And -4. Actually, it coincides with A. A and E meet the same place. 6, 210. 210 is 7 pi over 6. So 1, 2, 3, 4, 5, 6. G, 11 pi over 6. And -7. One, 2, 3, 4, 5, 6, 7. Okay. We're okay. And A and E are the same. They're the same point. Okay, so questions so far, how to graph these? Yeah. Okay. Yeah, it's not that hard. It's just, again, a lot of it's kind of like unicircle. Another thing we're going to do too is we're going to convert these to rectangle coordinates, like x, y coordinates. And a lot of it is just going to be using basic SOHCAHTOA rules. It's not that hard. Now, let's look at some of these questions here. Are there other coordinates that would also grab points A and E? Yes. That's infinite. Why is it infinitely many? You could just keep going round, or backwards, right? Totally. So name two of the points in the same location as A and E, with 1 equals 4. So you could say 4, comma 7 pi over 3. Or you could say -4, comma 10 pi over 3. That's a possibility. So there are infinite number of ways to describe a polar coordinate. Now we know that. So find a general way to represent all polar coordinates for B and C. So B, remember B was this. It was -2, comma 3 pi over 4. But you could put plus 2 pi k. Or you could switch it to 2, make it positive 2, and then opposite 3 pi over 4, that's going to be 7 pi over 4 plus 2 pi k. C, 3, comma -45 degrees plus 360 k, because it's in terms of degrees. Or you could do -3, and then opposite -45 would be 135 plus 360 degrees times k. Cool? You have it, go ahead.
Like, why would you need negative numbers if you can see it?
It's just so you know. That's all. Just so you understand how it works. Question? Brian, you had a question or?
Oh, no.
No? Okay. Yeah, Audie, go ahead.
So, yeah.
Cool. All right. Okay. So coordinate conversion, I just was talking about that. How do we do that? And I think my plan is, let's see if we can get, let's just see how far we get today. See if we get to page 3 or 4. Maybe example, at least get through example 5. Let's see if we can do that. That'd be huge. All right. So part B, coordinate conversion. If we were to superimpose the polar coordinate system on top of a rectangular coordinate system, so we know this from, we know it's from unit circle and trig. And that's theta. This point here is x, comma y. We know this. X over, so cosine theta is x over r. That makes sense, right? Sine theta is y over r. That also makes sense. So is x equal? And what is y equal? So that's one way of doing a conversion. That's kind of important to see. X equals r cos theta, y equals r sine theta. Also, this is part of the unit circle, right? or as part of a circle. We know this is true. So wouldn't then so you could kind of think like as if you were a substitute, what would happen if you substitute for x and r? You want getting this, right? What happens if you factor with r squared from the left side? What do you wind up getting? Or what if you cancel out the r squares? You get the Pythagorean trig identity. So you know it makes sense. We know this works. Yeah, I think that's all I need to say about that for now. Oh, another thing you need to recognize, tangent theta equals y over x, which makes sense, clearly. So that's also kind of important to know as well for the conversions.
When would you use which conversion? If I get r data, I get the x value, use this one. Or when you y value, use this one. If I give you y and x and you want the angle, use this one. Or use this one to part. So you've used these two.
So I probably should label this. To go from polar to rectangular. Rectangular is x and y, just so you know. Oh, bless you. And you'd use these two to go from rectangular to polar. If you're getting the rectangular coordinates on the polar coordinates, you'd use that. And when you have y over x, just do the inverse tan of it, and you get your angle. So, and you kind of know what the angle would be depending on the location, which quadrant you're in. So let's do some conversions right now. Questions so far? Nope. Okay. So I'll do part A of examples 2 and 3, and you guys then try examples B, or part B for examples 2 and 3. So here, yeah, so here we're given polar. So guess what? I'm going to say x equals 3 times cosine 5 pi over 6. So x equals 3 times, I should know my unit circle, negative root 3 over 2. So it's negative 3 root 3 over 2. And y equals 3 times sine. So that's 1/2, right? So that would just be negative 3 root 3 over 2, comma 3/2. Cool? Makes sense? Okay. Next up, and we want to keep this within 0 to 2 pi just to avoid confusion, because I don't want you doing, rarely do you do general solutions for polar coordinates. You just like to keep between 0 and 2 pi, keep it simple. So negative 1, 1. So tan theta equals y over x, so 1 over negative 1 or negative 1. Now, if you think about it, we got to keep it in the first rotation. So you're not going to do the true
Default for inverse tan. So the true default, remember, is from negative pi over 2 to pi over 2. What quadrant is that? Negative 1 pound 1. Second, and think about the referencing. I know the referencing is 45 degrees, right? Because, tangent is 1 over 1 and 1 over that, whatever. What would the angle be in radians for that? If you're in the second quadrant, you're seeing something like this. So that's a reference angle, so we see 3 pi over 4.
Right. But wait, do you guys see pi over 4 initially, or 3 pi over 4? Yeah, you're correct. And then r is just root 2, right? Because 8x squared plus y squared. So your coordinates are going to be root 2, comma 3 pi over 4. Okay, go and try parts B for examples 2 and 3. I'll just give you guys a minute or so to do that. Then we'll move on to the next page. And actually, while you're at it, do part C as well. Part C on the next page of example 3. Do that as well. Part B of example 2, part B of example 3, part C of example 3.
There's two answers.
Infinite amount of there.
Wait, which one are you talking about? Part B? No, it's only 1 point though, because you know you're going to be yeah.
But you can do negative two.
Yeah, you could do two.
Do negative two, 7.1.
Oh, I see what you're saying.
This is showing 0 to 2.
Oh, yeah, exactly.
Where's the negative two?
Wait, hold on.
Negative 3, 0 is negative 3.
Yeah, you should be getting this, guys, for
Oh, you're right.
Yeah, or do you need more skill? You need 1 second, please. I'm just getting it. Please hold.
It's negative 3, 0.
Wait, 4 to negative 4?
Oh, yeah, it should be
So
negative.
you guys got negative 3, 0.
Wait, am I getting
yeah.
Yeah, according to term, positive X, negative Y. Negative positive X. 7 pi over 4. Cosine
You get
is positive,
3, 0.
that's 7 pi over 4.
Cosine.
Yeah, okay, guys?
Negative 3, 0. Negative.
Yeah, because we're in the negative x-axis through comp pi.
Outside the traditional range.
Right. Okay. Questions? We good?
But it's still.
Duke, yeah.
Like, yeah, calculus are negative.
So you could say this if you want.
Yeah.
You could say that if you want. Well, I'll probably just put a condition for my own sanity when I grade these, like to make R positive. I don't know, but definitely for B, there's only one answer for B.
Yeah, so I was talking about negative 2.
Oh yeah, sure. Yeah.
How'd you know it was like, so it's just because there's two possible solutions that are.
Well, negative comma 0.
I hate that shit. It's not too late.
Which is high rating.
Not easy to
When I go on Thanksgiving break, I'm gonna be stopped by 3 different types of airports a year.
How do you do that?
1, 2.
I didn't really do that, but it's intuition.
Okay, so it's over.
If you do the math, it would be negative 3 squared plus 0 squared is R squared. So R is going to be 3. And then you do the inverse tan theta is 0. And that's going to be 0 at 0 or.
Oh, it's gonna be like 3 years.
Right. But when I solve for R, and the R is so that's why you have to then like kind of just look at the graph.
The negative 3, 0 is the same thing. as 3.
Yeah. Okay, let's move on, guys. What's that?
How do we know it's not?
Because you would not be on the negative x-axis then. All right, so this one here, guys, quiet please. Thank you. We have to use a calculator for this one. So, you guys, I need you to focus. I know it's been a long day. All right, so we got this. So really the rotation, remember, the rotation is kind of like this, right? That's your rotation. So I'll call this theta. Okay. So R squared will be 3 squared plus negative 4 squared. So R is just going to be 5. And then tan theta, that's negative 4, and that's 3. So tan theta is negative 4 over 3. So theta is inverse tan of negative 4 over 3. We do have, this is the tricky part, because when you punch in the calculator is going to say,
Calculator put in right.
well, it's going to give a negative answer. We want to get an answer from 0 to 2 pi. That was the condition that was in the instructions. So inverse tan negative. Hold on, let me switch to radians.
So technically.
Yeah, so you get negative 0.927.
You can add pi.
Yeah. Well, actually, no, you're gonna add 2 pi.
Wait, what, can't you add pi if it's tangent?
Do you want to get?
No, the location is quadrant 4 here.
Our location is quadrant 4, negative quadrant 4.
I thought you said you needed a range from 0 to pi.
Exactly.
Oh.
Yeah, dude.
Right, but.
Zero pi.
You just never want, generally you don't want R to be negative.
It's just cleaner not to if you could
Okay.
avoid it.
But it's
So you wind up getting 5.356. Add 2 pi to that. Yeah, 5.356. So the answer is going to be 5, 5.356. There you go. Okay. Okay, so good so far. Things seem okay. All right. Now let me do let's see how far we go with this exam 4. Might oh geez. Yeah, you know what? I think what I'll do is let me do exam 4. I'll stop there because opening exam 5 is really opening a can of worms. That's much better to do on Wednesday. So let's finish out exam 4 and then I'll go make some copies of your homework and then you guys just hang out. All right. So this is kind of somewhat exploring the graphs of polar, but I don't want to get into that today because it'll be a little rushed. So here's what we're gonna do. You're gonna figure out what these graphs will look like. So r equals 3, or theta equals pi over 4. Well, r equals 3. Remember what we had earlier, right? We remember we had this x squared plus y squared equals r squared. So what does that really mean? Really, that means that x squared plus y squared equals 9. So if you're given that,
You're given a polar equation, right, plus 3. They just want to circle the reason. Only one.
so you have to describe the graph. It's a circle centered at the pole with radius equaling to 3. And we're gonna do some really crazy graphs over the next couple of weeks, but we're just gonna keep it simple today. And in general, what is the graph of r equals k, where k is well, I'll get to that in a sec. The next one, theta equals pi over 4. So in this case, you know tan theta equals y over x. We know this, right? So what's tan of pi over 4? 1. So what does that mean? That means that y equals x. Just a line. That goes on forever. Each fraction, just a line. A line through the pole. It makes an angle of pi over 4 with the polar axis. Remember, the polar axis was just that. The polar axis, it's like the x-axis. That's the polar axis. So that's how that looks. Makes an angle of pi over 4 with the polar axis. In general terms, I don't want to move the screen, so I'll do the bottom of the notes up here. So generally speaking, it's going to be a circle centered at the pole with radius equals k. Or for this one, generally, that's going to be a line passing through the pole at an angle theta, or an angle K, sorry, an angle K with the polar axis. So yeah, that's all. So that's really what's happening. They will get a little crazy. They get a little crazy. We'll look at that. We use Desmos. We'll use a graph calculator to kind of make sense of all this. We'll do crazy stuff on Wednesday. So I'll stop there for today. Homework's gonna be textbook. Let me circle these problems and run and make some copies for you guys. So you guys hang out, relax, and it's been a long day for you guys. But we're done for today.